Doubts about the LK99 superconductor. It was not possible to repeat the results of Korean scientists. In late July, a group of South Korean researchers announced the discovery of a superconductor that works at room temperature and ambient pressure. Superconductors transmit electricity without resistance and have a number of properties that make them invaluable in technological applications. Unfortunately, attempts to experimentally and theoretically reproduce the results of Korean researchers have failed, and laboratories around the world report that they have found no evidence of superconductivity. There are losses when transmitting electricity. They result from the resistance in the wires. However, there are materials that conduct electricity without resistance, i.e. superconductors. They allow the transmission of energy without any losses. The world of science has long known and used many superconductors. However, there is a serious problem with them. Superconductors only work at very low temperatures, down to minus several hundred degrees Celsius, or extremely high pressures. A team of scientists from the startup Quantum Energy Research Center in Seoul on July 25 uploaded the results of their research to the archive preprint database, which showed that the material they developed, called LK99, is a superconductor and works at ambient pressure and room temperature. But the results of these studies could not be replicated. The search for a superconductor has been going on for decades. Some research teams have achieved interesting results in this field. For example, researchers from the University of Rochester have developed a superconductor that operates at a temperature of 14.4 degrees Celsius. Unfortunately, the material exhibits superconducting properties at the gigantic pressure of about 27,000 MPa, 39 million psi. LK99 is a mixture of powdered compounds containing lead, oxygen, sulfur and phosphorus. Heating them at high temperature for several hours caused the powders to chemically react and turn into a dark gray solid that, according to Korean researchers, exhibited superconductivity even at 127 degrees Celsius. The The Seoul-based researchers said the LK99 samples exhibit two key characteristics of superconductivity: zero electrical resistance and the Meissner effect, where the electromagnetic field in a superconductor is cancelled out, allowing the material to levitate. The reports of Korean researchers caused a sensation and prompted both scientists and amateurs to make many efforts to replicate the results of the Seoul scholars. However, attempts to experimentally and theoretically reproduce their results have failed. These unidentified superconducting objects, as they are sometimes called, appear on archive every year, says Ina Vishik, a condensed matter researcher at the University of California, Davis. None of the studies conducted so far to replicate the results of Korean scientists have provided evidence of any superconductivity. Attempts by a group at the National Physical Laboratory of India in New Delhi came to nothing. The researchers produced LK99, but observed no signs of superconductivity. Similar results were reported by a team of researchers from Beiyang University in Beijing. In turn, in an experiment conducted by scientists from Southeast University in Nanjing, China, the almost zero resistance of LK99 was observed, but at -163 degrees Celsius, well below room temperature, but high for superconductors.